We will now consider programming exercise 6.10. Use the isPrime method in listing 6.7 for testing whether a number is prime. And we're going to use that method to find the number of prime numbers less than 10,000. So if we review listing 6.7, we were given this method called isPrime, which returns a Boolean value. It has one parameter, number, that is of type integer. And it proceeds as follows. We're going to test every number from divisor, which we initialize to 2, all the way up to number divided by 2. When the user or the program passes in this number, this integer, to be considered to determine whether or not it's prime, we're going to loop and to determine if there are any divisors other than 1. So we start our control for our for loop, our control variable, we name divisor at 2, and we continue looping until divisor is less than or equal to number divided by 2 because of the symmetry of factors. And of course, we're going to increase or increment divisor by 1. Each time we're going to increment by 1 as we go through the loop. And the loop is simply going to test if number mod divisor is equal to 0. That means that there is a factor other than 1. This number has some factor. Then we're going to return false because that means that the number is not prime. If we get all the way through this for loop and we don't find any divisors at all, then that means that there are no factors other than 1, and so we'll return true, indicating that the number is prime. Now we want to write this program, this main method here. We're going to write a test program to determine the number of prime numbers less than 10,000. We're not going to list all of the prime numbers less than 10,000. We just want to determine how many of them there are. And so we'll get started. In order to determine how many, we're going to have some form of a counter. So we'll initialize a variable called count to 0. Of course, count is going to be an integer because we're counting how many exist. And so in order to do this, we are going to go ahead and loop and consider all of the possible prime numbers less than 10,000. Of course, this is going to be positive integers. So we'll say 4, and we'll have our loop control variable. We'll have an integer that I'll call number. And we'll start it at 2. And as long as number is less than 10,000, we'll loop and we'll increase number by 1. Will be our increment. We don't have to consider number equal to 10,000. We know 10,000 is not a prime number. We could, that would not affect the outcome, but it's just not necessary to consider that. And so in this loop, what we want to do is we want to consider each number and determine if it's prime. If it is indeed prime, then we want to increase our count. And so we're going to say if, we're going to call this method isPrime. And we're going to use as our parameter, we're going to use number. And this is going to tell us whether or not number is prime. So if number is prime, then all we really want to do is increase our counter. Increment our counter. All right, and once we have gone through and investigated each number less than 10,000, then we're going to simply report the outcome. All right, so that should do it. We report the outcome. So let's run this and see how it works. See what it tells us. So the number of prime numbers less than 10,000 is 1,229. There you have it.